In this video, we're going to talk about writing vectors in polar or trigonometric form. So as you see here, we have vector v, and we've placed vector v in standard position. Now our angle theta here is an angle formed by a counterclockwise rotation from the positive x-axis to our vector v. And vector v, when expressed as the sum of two unit vectors, is ai plus bj. And what we want to do is convert that from ij form into polar form. So we need to come up with a slick way to rewrite a and b using the magnitude of our vector and our angle theta. Well, we know that cosine of theta is equal to a over magnitude of v, which means that a is equal to magnitude of v times the cosine of theta. So the first step to writing this in polar form is to replace the a with the magnitude of v times cosine of our angle theta. Now what about the variable b? Well, we know that sine of theta is equal to b over magnitude of v. That means that b is equal to magnitude of v times the sine of theta. So the second step in writing this in polar form is to substitute for b magnitude of v times sine of theta. And when we do that, we will see that a vector, when written in polar form, looks like this. Our vector v will be equal to a, but a is equal to magnitude of v times cosine of theta. I plus bj, but in this case our b will be magnitude of v sine of theta. So we'll have magnitude of v cosine of theta I plus magnitude of v times sine of theta j. Let's see if we can find the magnitude and direction of this vector, and we're going to round to one decimal place. So we're given a vector v. Vector v is equal to negative 1.8 I minus 3.5 j. And we want to find the magnitude and direction of this vector so we could write it in polar form if we wanted to. So let's start by finding the magnitude. The magnitude of v is equal to the square root of a squared, which is negative 1.8 squared, plus b squared, which is negative 3.5 squared. Well, that's equal to the square root of 1.8 squared is 3.24, and 3.5 squared is 12.25. So that's equal to the square root of 15.49. And that's approximately 3.9 units. So our magnitude of this vector is about 3.9 units. Now let's find the direction. To find the direction, we'll use tangent of theta equals b over a, which means that tangent of theta is equal to negative 3.5 over negative 1.8. And we'll use the inverse tangent function of our calculator to find theta. And we get that theta is approximately 62.8 degrees. But we know that can't be right, because if we were to draw this vector in standard position, we would have to go minus 1.8 units left and then down 3.5 units. And that would put this vector in quadrant 3. Well, 62.8 degrees is a quadrant 1 angle. So let's just use that quadrant 1 angle as our reference angle to find a quadrant 3 angle. To find that quadrant 3 angle, we would add 62.8 degrees to 180 degrees. And that would give us, when rounded to one decimal place, 242.8 degrees. So the magnitude of this vector would be 3.9 units, and the theta would be 242.8 degrees. Now let's see if we can write a vector in ai plus bj form when we're given its magnitude and its angle of rotation theta. So here we have magnitude of v is equal to 6/7 and theta is equal to 225 degrees. And we know when written in polar form that this vector will look like this. Vector v will be equal to magnitude of v times cosine of theta I plus magnitude of v times sine of theta j. Now let's just fill in the blanks. Magnitude of v is 6/7 times the cosine of theta, which is 225, times I, plus 6/7 times sine of 225, j. And that's equal to 6/7 cosine of 225. 225 is in quadrant 3, but we can use 45 degrees as our reference angle. Cosine of 45 degrees is square root 2 over 2, which means cosine of 225 will be negative square root 2 over 2 times I plus 6/7. Again, here's sine of 225, but that's going to be the opposite of the sine of 45 degrees. So that would be negative square root 2 over 2 times j. This will be equal to negative 3 square roots of 2 over 7I plus 6/7 times a negative square root 2 over 2. Well, that'll be a minus 3 square roots of 2 over 7j. So there is this vector written in ij form.